Today you will learn about function notation. It sounds like it should be really scary, but it's actually just another way of writing equations into variables. So let's go ahead and take a look. So what we're used to is on the left-hand side where it says old language. You can see the problem reads, the equation y equals 2x plus 7 can be used to calculate the cost of a pizza y based on x toppings. Determine the cost of a pizza with 3 toppings. Remember, toppings was x, so that means x is 3. So to determine that cost, I would just substitute 3 in for x into my equation. So I have y equals 2 times 3 plus 7. That means that y equals 13. So the cost of a pizza with 3 toppings is $13. As an ordered pair, that would be 3, 13. Now, remember from when we talked about functions that x is the input value and y is the output value. So you're putting something into a function and getting something out. So in this case, we're inputting 3 into our equation or our function, and we are getting 13 out. Now, our new language, our function notation language, is going to look like this. We're going to rewrite that equation using what we call function notation. It's going to look just like this. It's read f of x equals 2x plus 7. So the function f of x equals 2x plus 7 can be used to calculate the cost of a pizza, f of x, based on x number of toppings. So really, f of x is just a fancy form of y, basically, in this case. F of x is replacing y. F of x means the function of x. So basically, it's giving us an additional piece of information. It's telling us that this equation is actually a function. It passes the vertical line test. It has no repeating x values. F of x is read just like this, f of x. If I want to show the cost of a 3-topping pizza using function notation, it would look something like this. It would be f of 3 equals 2 times 3 plus 7, or 13. So f of 3 is equal to 13. Basically, with function notation, what you see at the top of this screen is what you need to know. You're going to put in parentheses that x value, and then whatever you get out of that, that's technically the y value. It's the function value at that particular x value. So you're putting in that input and getting out the output. F of x is equal to y. Like I said before, f of x is really just a fancy form of y. So take a look at this first example. We're seeing that f of 4 is equal to 12. So the input value is 4 and the output value is 12. Remember, that is also the x value and the y value. Input is x, output is y. So this can be represented with the ordered pair 4, 12. This is really just some practice using the notation because I don't want you to be scared of that notation. In example 2, a question asks you to find f of 5. So is 5 an x value or a y value? You'll notice that 5 is inside of the parentheses here. So that is technically an x value. And then in example 3, it says a question asks you to find x if f of x equals 7. Well, remember, f of x is just a fancy form of y. So that's another way of saying y equals 7. So is 7 an x value or a y value? It's a y value. So let's take a look at number 1 down here at the bottom. It says a question asks you to find f of negative 7. Is negative 7 an x value or a y value? Since it's inside the parentheses, it would be an x value. And then if a question asks you to find x, if f of x equals negative 7 is f of x. F of x is a fancy form of y, right? So negative 7 is technically a y value. Go ahead and take a second to try out numbers 3 and 4. Pause the video, get answers down for 3 and 4, and then unpause and see if you get the correct answer. So in number 3, we are given that f of negative 2 is equal to 0. That means that negative 2 would be the x value and 0 would be that y value. And then in number 4, f of 5 is equal to 10. 5 is that x value since it's inside the parentheses. 10 is the y value since it is the function value when x equals 5. Now let's take a look at these tables. These tables are functions. Notice there are no repeating x values there. Every x value has one specific y value that it goes with. We are asked to find f of -2 for that first table. Well, -2 is an x value. So what we do is we look at our table, figure out where x equals -2, what the function value is at that point. It's this one right here. So when x was -2, the function value was -10. So f of -2 is -10. And then if we were to look at this kind of in the opposite direction, it asks us to find the x value if f of x is equal to 14. We'll use your table, find where f of x is equal to 14. That's this right here. At that point, x was 6. So when f of x is equal to 14, x is equal to 6. Go ahead and pause the video and try out 2 and 3 without me, and then come back and unpause to check your answers. So in number 2, they're asking us to find f of -1. So that means x is -1. So go in your table, figure out where x is -1. Notice the function value is -3 at that point. So f of -1 is equal to -3. And then if f of x is equal to 5, we are supposed to find the x value. So look where f of x is equal to 5. Make sure you're looking in the correct column because f of x is 5, right? I know that there is an x value of 5 in that table as well, but we're looking for an f of x value, a function value equal to 5. That's this right here. And x would have to be 2 at that point. So x is 2 when f of x is equal to 5. And then in table number 3, f of 0 would be -2. And if f of x is equal to 62, the x value is 4. Just a little practice in reading these tables. The next couple problems deal with functions that are shown as graphs. So we're trying to figure out what function notation looks like with a graph. So take a look at number 4. We're trying to find f of -5. So go to where x is -5, because remember, it's inside the parentheses there. So x is -5. Go ahead and follow that vertical line right on up to the curve there, to the actual graph itself. It's this point right here. So follow that horizontal line over to that y value or the function value when x is -5. The function value is 5. So f of -5 is 5. And then we can do the same thing for this next one, f of -3. So find -3 as the x value on that x-axis. Follow the vertical line on up until you hit the curve and look for the y value at that point. Notice it is 1. So f of -3 is equal to 1. In number 5, we have a discrete graph. And we can do the exact same thing. So x is -1 for this first one. We're trying to find f of -1. Go to where x is -1 and look at what the y value is there. That function value when x is -1 is 0. So f of -1 is 0. And then f of 2, go to where 2 is located on the x-axis. Follow that up the vertical line and look for the function value at that point. It is right up here. It is 5. f of 2 is equal to 5. Pause the video and see if you can try out number 6 without me, and then come back and check your answers. So we're trying to find f of -4 for this function. So go to where x is -4 and follow that vertical line down till we hit the actual graph itself. We're going to hit it right here. So look at that y value. That y value is -2 right there. So f of -4 is -2. And then if f of x is equal to 1, that's really a y value. So go to where y is equal to 1. On the y-axis, find 1. Do you have to go to the right or to the left to hit the actual graph? You're going to go to the right. So follow that over until you hit the actual graph and look at what the x value is right there. The x value is 2. So if f of x is equal to 1, x had to be 2 for this function. Okay, now let's look at function notation when the function is given to you as an equation. So for number 7, we are told that f of x is equal to 3x plus 2. I want you to find f of negative 2 for letter A. So that means x is negative 2. Okay, I'm going to go ahead and substitute in a negative 2 everywhere I see an x. So I was starting with my function. I had f of x equals 3x plus 2. I substitute in negative 2 every time I see an x. And remember, there's nothing to evaluate on that left-hand side because f of negative 2 just means what is the function value when x is negative 2. So I'm not evaluating anything on the left-hand side, just the right-hand side. So use your order of operations to evaluate on that right-hand side. F of negative 2 would be negative 6 plus 2 or negative 4. And you could actually write that as an ordered pair as well. So if I wrote it as an ordered pair, I would be looking at the point negative 2, negative 4. Because remember, negative 2 is my x value. Negative 4 is my function value or my y value in this case. So now let's go ahead and see if we can find f of 5. Pause the video and see if you can go ahead and substitute and find that, and then come back and check your answer. Start with the function, substitute in 5 for x, and then evaluate. So f of 5 would be equal to 15 plus 2 or 17. The ordered pair to go with that would be 5, 17. And then we can also work in the opposite direction. So if f of x is equal to negative 16, I want you to find x. So we're basically working backwards. We're going to substitute in negative 16 where we see f of x. So we're going to replace that f of x with negative 16, and then it's just a two-step equation. So we're going to go ahead and solve. We're going to subtract 2 from both sides and then divide both sides by 3. So x is negative 6 when f of x is equal to negative 16. And that means your ordered pair would be negative 6, negative 16. Functions can be named really using any letter, but we tend to use the kind of middle third, I guess, of the alphabet more than anything else. So we already used F in number 7. We're going to use G as our function for number 8. Like I said, you can really name it anything you want. So in number 8, we are given that g of x is equal to negative 4 plus 1. And I want you to go ahead and find g of 1. So we're going to start with the function itself, and then anytime we see an x, replace it with 1. So g of 1 is going to be equal to negative 4 times 1 plus 1 when you substitute that in. That's negative 4 plus 1. So g of 1 is equal to negative 3. And that means the ordered pair would be 1, negative 3. All right, let's work backwards for this one. So this time we're given that g of x is equal to negative 19, and we are trying to find x. So start with your function, and then replace g of x with negative 19. Now it's just a two-step equation. Go ahead and solve it. Subtract 1 from both sides, and then divide both sides by negative 4. So x would have to be 5. And that means your ordered pair would be 5, negative 19, because g of 5 is equal to negative 19, according to what we just calculated. In part C, I want you to find g of 7. Try pausing the video, find it yourself, and then come back and check your answer. So start with the original function, substitute 7 in for x. G of 7 would be equal to negative 4 times 7 plus 1, or negative 28 plus 1. So G of 7 is equal to negative 27. The ordered pair to go with that would be 7, negative 27. So as you can see, function notation really isn't that confusing. It sounds very scary, but it's not that bad. It's really just another way of writing the equations that you're used to. It's just giving you a little bit more information to then tell you that this equation is also a function. If you have any questions, we will touch base during ASA tomorrow. Thanks, guys.